So am I audible to all of you? So am I audible to all of you? Okay, fine. Let us start it, right? So how will you start? In the last class, I guess all of you have written down the numerical that we taught to you. Hmm? So this was the question that we basically discussed. Okay. So in this question, what is written? First of all, design of RCC slab Cluvert for IRC class double LH. Right? Now, in this case, following are the parameters that are given now. If you jot down the parameters, you'll see that number one, first of all, the carriageway. This is a two-lane carriageway, 7.5 meter wide. Now then, we'll have footpaths, 1 meter on either sides. So, all of you, please take out your copies. Okay, it will be better for you if you solve this numerical. Hmm. So if you can see here, first of all, the carriageway is 7.5 meter wide. Then the footpaths are 1 meter on other side. Clear span is 6 meter. Wearing coat is 80 meter. Width of bearing is 400 mm. Okay. Now, if you can see it, the loading is IRC class AA tracked vehicle. Basically, while solving these numericals, this is the first important factor that we need to consider. And this is materials. Materials is what M25 grade and Fe4Y5 HYSD bars. Now the data. First of all, the clear span. Hmm. Clear span is what? How much? 6 meter. Width of bearing 400 mm. Now this clear span and width of bearing, if you see here, it is given. Clear span 6 meter, width of bearing 400 mm. IRC class double track vehicle loading and M25 grade of concrete. These are the things that are what given. Okay. Now if you see here, the permissible stress, that means sigma CP and sigma ST, small m, q, j. Now these are the things that you can find out we discussed in the previous classes. If you see in table 3.4 of the book, I asked you to take a screenshot. I remember. From table 3.4, we'll be getting these values. Okay, these are the values that we'll be getting from table 3.4. Sigma ST, sigma CP. Okay, for M25 grade and Fe415 HYSD bars. That means Fe415 and M25, if you see it, the values are given in this table 3.4. Okay, you can do one thing. I'm just going to that table. You just take a screenshot of that. Okay. This is the table. Now this is the values of M25. So better you remember the values. Mostly M25 numericals are only there. Okay, just take a screenshot and let me know once you're done taking the screenshot. Is it done? Done. Okay, fine. Fine. So most of you have done it. So let us go to the numerical part. If you see here from the M25 and FE415, you are getting what? You are getting these values. Fine. Now, after that, you will be finding out the depth of slab and effective span. Now, first of all, you have to do look for this kind of numericals. There are no codes. So basically, you will have to remember the steps how to do it and which part comes after which part. Okay. So first of all, and better you like this: number one, data; number two, permissible stresses; number three, depth of slab and effective span. So how will you find out the depth of slab and effective span now? If you see here, assume thickness of slab at 80 mm per meter span for highway bridge decks. Now we'll have to assume what? Per meter span. For 1 meter per meter, it will be 80 mm. That means for 6 meter span, it will be how much? 480 mm. Why? Because 6 meter is given in the data. The clear span is 6 meter if you see from the question. Ah, so you have assumed it like this. Overall thickness of the slab. Now overall slab depth. Overall slab depth is what? 500 mm. This 500 mm overall slab depth. This is to be assumed. There are certain values that you always assume. So you have to adopt overall depth of slab equal to 500 mm. Okay. Now after that, if you see here using 20 mm diameter HYSD bars with clear cover of 30 mm. Effective depth. Now you all remember, I think so, from DOS class, what happens is that like this, if it is a beam in design, how will you consider the effective depth? Okay. Now if this is the if this portion is the clear cover, okay, then the effective depth will be how much? From this edge, from this edge, we'll consider here, come down, 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 just up to the center of this. These are the bars, right? Just up to the center of these bars, we'll be considering what? The effective depth. That means what? The effective depth equal to total depth 500. Then you have to subtract this blue portion. Oh, sorry, this blue portion, right? This is the clear cover. So we put minus 30, and actually what? We'll have to subtract this blue portion plus the half of this reinforcement diameter. That is why we are doing in this sense. Okay, I hope you are understanding everything, this part also. That is why we are doing it 30 plus 10 40, it comes out to me. So up to this center depth, that means it is 460 mm, right? So in this way we will be computing the effective depth. Now after effective depth, what is there? Width of bearing is equal to 400 mm. Now if you see here the question, it is given that width of bearing, hmm? Width of bearing is given as 400 mm. Yes, anyone? Any problem? Any problem? So this width of bearing is given as 400 mm. Now, these all are the important things. The effective span of the someone is muted, unmuted. Just mute yourself. Huh? So now effective span is the list of what clear span plus effective depth or center to center of bearings. Now clear span plus effective depth means that the clear span is 6 mm and the effective depth we found out as far as 460 mm. Either that one or center to center of bearings. Now how much is the bearings? Bearing is 400 mm, right? And the span is 600 mm, right? The bearing is in both sides, right? If the bearing is in both sides, then if the bearing is in both sides, then you'll have to consider the fact that half from one bearing and half from other bearing. That is why it is coming to be 40. Now the bearing is I'm disabling the screen sharing because your friends are asking me so many times entering after the class has started. You know, many of the people are entering, so it's disturbing. So I have to disable this and then again allow them to enter. Please ask them to enter in time. Now, if you see the effective span, L is what? 6.4 meter. Now, this is the cross section of the deck slab. So, this cross section of the deck slab will be looking like this. Okay. So, this is how it will look. Now, these diagrams, these are all based upon IRC class AA loadings. In IRC class AA loading, this is how the width and all are there. Now, if you consider, we have to find out the design. What? Now, this is the cross section. Now, this cross section you can draw, also draw what on the basis of what do you call it? The given data. Hmm. The given data you can draw. If you see, carriageway is 2 lane, 7,500 mm. Footpath is 1 meter on other side. That is why this 7,500 is there, then 1,000 is there. On either side. Now the wearing coat is 80 mm, 500 mm deck slab we consider. So in this way it will be there. Okay. Now if you see, uh, just do one thing. I'll give you 3 minutes. Just draw and write the data everything, and please tell me once you are done. Okay. I'm just waiting for you to complete. Please tell me once you are done writing this. Okay, students, please tell me once you are done writing this. Okay, good, very good. So yeah, someone wants to speak something. Good. Someone wants to speak something. ताना पेखी.
यस सर.
हाँ बोलो कुछ बोलना है.
नहीं नहीं सर.
ओके तो म्यूट कर दो. Okay, so we are doing now up to this part. Is it over? Now if you see, now if you see, we'll have to find out the dead load bending moments. Okay, so how will you find out the dead load bending moments? Look at this first of all. The dead weight of slab is 0.5 into 224. Now, how come this two come? So first of all, 0.5 means what? 500 mm is the thickness of the deck slab, right? So 500 mm thickness means what? It will be 0.5. So no. And this 24 is the unit weight of concrete. This 24 is the unit weight of concrete. So that is why 0.5 into 24 gives you 12 kilonewton per meter square. Now dead weight of wearing coat 0.08. 0.08 why? Because the thickness of the wearing coat is 0.08 meter. and 22 is the what unit weight of that material that is used for making new wearing coat. Just remember these two. The wearing coat of concrete is 24. I guess every one of you know, and the wearing coat of this wearing material, it is what 22. Therefore, the total load. So eventually we
Hello,
will
sir.
find. Yeah, please. Are
So
you
why are we using 20? Why are we using 24, sir? Why not 25?
unit weight of concrete is 22, 24. If you see unit
Yes,
weight,
sir, but that's for PCC. Like for RCC, why not 25? This bridge is RCC, sir.
yeah, but the unit weight of concrete is 24 per for concrete, right? RCC. This is RCC means what? It is reinforced cement concrete. But here, if you see the unit weight of concrete, look, we are considering only the PCC thing. Okay, RCC we are not considering because reinforcement we are not considering here up till this step. So we just consider the fact as PCC. That is why we are considering is this 24. Okay, is it okay? For RCC, had it been considered RCC, we can write 25. Okay,
Okay, sir.
and like the if you see here, the wearing coat is 22. That is why we are considering it in this manner. Now we are getting the total load as what? 12 plus 1.76. That means what? 14 kilonewton per meter square. Now the dead load bending moment will consider. Now look, we got the total load as how much? 14 kilonewton per meter square. Yes. Now, if you consider the length or the span, huh? The effective span is how much? L equal to 6.4 meter, right? Now, the load is given as 14 kilonewton per meter square. Now, if you use this expression, now if you consider this is as UDL, then we will be getting what? W what? L square by 8. Yes, WL square by 8. So, for this, so this is how we'll be finding out. 0.125 means 1 by 8. And this is the W and this is the L square. And it comes out to be how much? 72 kilonewton meter. Is it clear up to this step? Every one of you, is it clear? Every one of you, is it clear up to this step? Can anyone respond? Okay. So please write these few lines and write the reasons what you are considering. Just write these steps and let me know.
Hello, sir.
Yeah.
I have a question, sir.
Yeah.
Sir, that unit weight. So in the question, it says design an RCC slab. So, sir, if the question says design an RCC slab, but we're using PCC unit weight, sir.
No,
Sir,
look,
any reason?
look, Michael. One unit weight it doesn't matters that much. I know in accurate manner or in for more accurate purposes it will be 25 for RCC. Huh? But this calculation is being done using 24. Yeah, you can do it using 25. I agree with that. But then even considering 24, I don't think so that it will cause much difference. Because if you see here, the dead weight will be how much? 25 into zero point 0.5 is 12.5, right? And here it is how much? 12. So zero point 0.5 kilonewton per meter square. Okay, it's okay. Doesn't matter much. Is it okay? But in general terms, we generally consider this as 24 only. These are in whatever you competitive exams also, if they ask you, in most answers it is like for RCC PCC it is different, I know, but then in most answers it is 24 only for conventional purposes. I hope you understand. I hope this is clear.
Yes, sir.
Okay, someone asked me to explain the dead load bending moment. Okay, fine, I'll explain it to you again. So if you see here, the dead weight of slab, the slab weight is how much? 0.5 into 24. Just now we discussed this 24 is the unit weight of concrete and 0.5 is what? This 5 mm, 500 slab deck slab, right? So this 0.5 is coming from this. Then we go to what? Dead weight of concrete. If you go to the dead weight of concrete, if you go to dead weight of slab, this is, I think so, it is clear. After that, if you go to dead weight of wearing coat, huh? This wearing coat, this is the unit weight, and this is the thickness of the wearing coat. Why? Because it is here 0.80 mm. This was for this one, the first one, so it was 500 mm, and this was for 80 mm, so this is like this. Therefore, the total weight, load will be how much? This and this. Are you getting me? Are you getting me up to this point? Please answer. Then, if you come to the next step, it is what? Dead load bending moment. Bending moment means what? This will be an UDL, right? Kilonewton per meter square. And we all know the bending moment expression for an UDL is this one, WL square by 8. That is why we are finding it in this manner. Okay? This is how it has been done. I hope this is clear for everyone. Now we'll go to the next part. Once we are done with dead load bending moment, now we'll go to the live load bending moment. Now, generally the bending moment due to live load will be maximum for IRC class A vehicle loading. Generally, the bending moment due to live load will be maximum for IRC class AA track vehicle loading. Now, remember this impact factor for IRC class AA track vehicle is 25% for 5% 5 meter span, decreasing linearly to 10% for 9 meter span. Now we all know here what the span is 6.4 meter. Now for 5% 5 meter span, it is what? 25%. Now look, if you consider for 6.4 meter span, remember one thing. Now there are two values. For 5 meter span, it is 25 meter. For 9 meter, 25%. For 9 meter span, it is what? 10%. Now we have to find out for 6.4 meter span. This basically is what the interpolation thing. Okay, this is basically what? This is basically the interpolation thing. So how it is been done? Look, let me write it here. For 5 meter, it is what? 25%. Then for 6.4 meter, we all don't know. And for 9 meter, it is 10%. Now, how to find out this one for 6.4 meter? So this thing you'll have to find out what? This thing you'll have to find out by considering the fact that this impact factor can be found, this one, by the fact that interpolation. Okay. Remember, this thing is to be found out by interpolation. Okay. So how did you find out? How will you find out this? Look, first of all, this 25 is always there. Now this 15 by 4, how did this came? Minus 15 by 4. 25 minus 10 is 15. So it came from here, and 9 minus 5, it is 4. It came from here, from this ratio. That means what? If you see here, in order to find out for 6.4 meter, how will you have to find out? This is basically the expression. You have to consider our two ratios, 25 by 10, 25 minus 10 and 9 minus 5, and then multiply into 6.4 minus 5, and then overall you have to subtract from the bigger value. This is the interpolation thing. Yeah, 19.745. Yeah, fine. That's why we are considering it 19.7. I hope this is clear. Michael, is it clear? Hello, Michael, is it clear? Now, after finding out this interpolation, the tracked vehicle is placed symmetrically to the span. So, if the tracked vehicle is placed symmetrically to the span, then the effective length of load, how will you find out? Effective length of load equal to 3.6 plus 2 into zero point 0.5 plus 0.08. Now look, this is placed symmetrical on the span. I'll explain to you about this 3.6. Can anyone say me how this 3.6 came? If anyone can say, you can speak up, or else I'll say it to you in 1 minute. This 0 0.5 is the thickness of the slab, and this is the thickness of the wearing coat. I hope this is clear. Now this 3.6 thing, this 3.6 thing, how did it came? Anyone can say? Give me 1 minute. I'll give you 1 minute. If you can say, you can say, or else I'll show it to you. This 3.6 thing came from this IRC class AA load track vehicle. If you see there in the diagram, the width of the track is 3.63600 mm. And the very first figure that you drew in class. Okay, so this is how you'll be finding out. Now, after that, if you see here, I hope this is clear up to this part. Effective length of the load. This effective length thing is clear, I think so, for every one of you. So let us stop it here.